Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Welcome back. Problem 9.13. So in this problem, it is given that for beam and loading shown, determine the deflection at point C. Use E is equal to 29 into 10 to the power 6 psi. So you can see this figure. The beam is simply supported beam with pin support at A and roller support at B. Clear? The cross section of beam is given. It is W14 by 30 beam. There is a concentrated load at point C, which is P is equal to 35 kips. The total length of beam is given as L and distance of point C from point A is 5 foot. So first of all, we have to find the deflection at point C. So let's start with the solution. Clear? So first of all, you have to draw the free body diagram of this beam. Clear? So let me draw it. So this is beam. Clear? This is point A. This is point B. Clear? There is a reaction force at point A, which is RA. There will be a reaction force at point B, which is RB. So at point C, on which there is a concentrated load, P is applied, which is equal to 35 kips. Clear? And this distance is represented as A, which is given as 5 foot. Total length of the beam is L. Clear? So let we take this distance as distance B. Clear? So as we know that total length L is equal to A plus B. Clear? So we can calculate B is equal to L minus A, which is equal to 15 minus 5, which is equal to 10 feet. Clear? Now we will apply the equilibrium condition that sum of all force along y direction is equal to 0, and the second is sum of all movement about any point is equal to 0. Clear? So from first, sum of all forces along y direction is equal to 0. So you can see RA and RB is acting upwards. So RA plus RB is equal to P. Clear? So this is one equation. Now we will apply sum of all movement about, let's say, about point B. Clear? So about point B is equal to 0. So you can see at point B there is reaction force and the perpendicular distance is R and it is producing a clockwise. So it will be minus RA into perpendicular distance is L. And the second moment that is produced by this P, and it will be counterclockwise, so it will be positive. So P into this perpendicular distance is B. Clear? P into B. Their sum must be equal to 0. So it means that RA is equal to PB over P into B over L. Okay, clear? So this is the reaction force. You can put the value of P, B and L, and you can also find the numerical value. Now you have this RA, and from here you can see that RB is equal to P minus RA. Clear? And P minus RA is PB over L. Clear? And that is equal to, if you take the LCM, it will be equal to PL minus PB. Clear? So this will be RB. Or RB is equal to, if you take P as common, so it will be L minus B divided by L. And we know that L minus B. A plus B is equal to L minus B is equal to A. So this term will be A. So it will be PA over L. So now we have the reaction forces RA, which is equal to PB over L, and RB is equal to PA over L. So these are the reaction forces that is acting upward. Clear? Now for finding the deflection, we will use this equation EI into d square y over dx square is equal to moment. So we will need moment. Clear? So for moment, we will section the beam over here as well as over here. Why? Because here if we use this section, clear? So here we have boundary condition that at x is equal to 0, y is equal to 0, and there is no other you can say there is no other boundary condition that we can apply it over here, because here you can see after the load the deformation will be like this. So you have to find this deflection. Clear? So here at x is equal to, I will write over here, at x is equal to A. So y will be equal to deflection. Similarly, at x is equal to A, we have dy over dx is equal to slope. Clear? So that's why we will take the moment, the section of this portion as well. Okay, so let's move. You will understand in a while. So first we will section the beam over here. If we section the beam over here, so it will be like this. So this is the reaction force RA. Clear? And there will be a shear force and a bending moment as well. Then let this distance is x. This is shear force and this is point J. This is point A. So this is for x is greater than 0, x is greater or equal to 0, less or equal to A. So here we will apply equation the sum of all moment about point J is equal to 0, counterclock is positive. So you can see only at this J point there is a moment which is counterclockwise, that is positive, and due to this reaction force which is RA and perpendicular distance is x, there is a moment which is clockwise. So it will be minus RA into x. Clear? So we have moment is equal to RA into x. And if you put the value of RA which is equal to PB over L, so it will be equal to PBX over L. Clear? So this is the moment equation for the portion of the beam in which x is equal or greater than 0 and less or equal to A. Now we will also take this section 2. Let this is section 1, section 2. So this is for section 1. Now for section 2, I will draw the beam, the free body diagram. So if you cut it like this, so this is reaction support RA, this is point A, this is point C, where P is applied. Clear? This distance was A. Clear? And let the distance from point A to where you cut the section is X. So if you cut the beam at this point 2, clear? So there will be a shear force V and there will be a reaction bending moment. And let this point is again J. So we will apply equation sum of all moment about point J is equal to 0, taking counterclockwise as positive. Now you can see at point J there is a moment which is counterclockwise, so it will be plus. Now due to this reaction force minus RA into X, which is producing clockwise, and again this P is also producing a counterclockwise rotation. So there will be a movement. Clear? There is a movement which is again producing a counterclockwise rotation. Okay, So RA is producing clockwise and P is producing counterclockwise. So it will be equal to plus P into this distance will be x minus A. Clear? P into x minus A. Their sum must be equal to 0. So this moment will become equal to RA x minus P into x minus A. So again RA is equal to PB x over L minus P into x minus A. Okay, so again if you take P by L common from both, so it will be P by L, and here we will only have B into x, so it will be Bx, and here minus L into x minus A. So again if you multiply it, it will be the same, and if you multiply this P by L with this, so it will be minus P into x minus A. So this is the equation of movement for x is greater than or equal to A and less or equal to L. Clear? Okay. Now we have two moment equations. Clear? So we will apply for this. I will draw the line. So for here we will apply this equation, which is equal to EI into d square y over dx square is equal to moment, and this moment is equal to PB into x over L. If you integrate it first time, so you will get, I will not write integrating it first time, EI into dy by dx will be simply equal to P over L px square over 2 plus C1. Then again integrating it, so it will be equal to EI into dy, EI into y only, because integrating dy by dx will be equal to y, and it will be equal to P by L bx cube over 6 plus C1x plus C2. Let this is equation number 1 and this is equation number 2. Now we will apply the same equation for the second section of the beam, that is EI into d square y over dx square is equal to P over L into bx minus L into x minus A. So integrating it once, we will get EI into dy by dx is equal to P over L, which is common in both terms. It will be equal to bx square over 2, and it will be L into x minus A whole square over 2 plus C1x. No, sorry, not C1, because C1 and C2 are here. It is another constant, that is C3. In clear? So these are unknown constant. Again, if you integrate this equation, so we will get EI into y is equal to P over L into bx cube over 6. Clear? And this will be minus L over L into x minus A whole cube over 6. Clear? Plus C3 into x plus C4. Now let this is equation number 3 and this is equation number 4. Now you can see we have 4 unknown constant and we have 4 equations. So this is equation 1, C1 and C2 are constant, and here C3 and C4 are constant. And we have only this boundary condition that at x is equal to 0, which we can apply to this. At x is equal to 0, y is equal to 0. So we will apply it on this equation 2. Put in equation 2. Put in equation 2. So x is equal to 0, y is equal to 0. So this term will be 0, this term will be equal to 0, and we will get C2 is equal to 0. Clear? Now again we have the second boundary condition that at x is equal to L. At x is equal to L, we have y is equal to 0. So we will put it in equation number 4. So when you will put it in equation number 4, so this will become equal to, this will become equal to y will be 0 here, so it will be 0. It will be equal to p over L into bl square, bl cube over 6, bl cube over 6, and this x is equal to L. Clear? It will be 1 minus 1 over minus L over 6 into L minus a whole cube. There, plus C3 into L plus C4. Clear? So we will get this equation. Here you can see that C3 and C4 are again unknown, so we cannot use further boundary condition. So what we will do is that now we know that at x is equal to a. Clear? At x is equal to a, dy by dx is equal to slope. Clear? And it will be used at x is equal to a. You can put it in equation number 1 and as well as in equation number 3. Where is 3? This is 3 equations. So you will see that left hand side of both the equations are same, so we can equate equation 2 and 3. So put x is equal to a and equate 2 and 3. What we have to do is that we have to put x is equal to a in equation 1 as well as equation 3, and we will equate it. So again you have both hand sides, left sides are same, so we will take it. You have to put x is equal to a, so it will be equal to pb a square over L 2L, sorry. Clear? PB square L plus C1 is equal to this hand side, which is equal to P over L. Here if you put x is equal to a, so it will be P a square over 2, and x is equal to a, so this term will be 0, and plus C3. So you can see this term and these terms are same, PBA square divided by 2L divided by 2L. So it means C1 is equal to C3. Clear? So what we have is C1 is equal to C3. Okay, so let's move further. Same case you will apply at x is equal to, let me move further. You will use at x is equal to a, deflection is equal to y is equal to deflection. Clear? So you have to put it in equation number 2 and 4, and you have to equate it because the left hand side of both equations are same, which is ei into y. So put in equation 2 and 4 and equate them. So what will you get is that this, you will have PBA cube over 6L plus C1 into A plus C2 is equal to, now you will use this P over L, P B A cube over 6, clear, and you put x is equal to a, so this term will be 0, clear, and we will have C3 into a plus C4. Okay. So as you can see that C1 is equal to C3, so it will C1A and C3A. Because C1 is equal to C3, so we can also write C3 into C1 into A. And this term are also same, so they will cancel. So it means that C2 is equal to C4. Now from above, what we have is that C2 is equal to 0. So it means that C2 is equal to C4 is equal to 0. Now you have the value of C1, C1, where is C1? C1 is equal to C3, clear? C1 is equal to C3. Okay, so C1 is equal to C3. Where we have utilized that C3. Now you can see you have C4 is equal to 0, clear? That is 0 from here. So you can calculate C3 as well. So C3 is equal to P over L into BL cube over 6 minus L over 6 into L minus A whole cube. Clear? Or you can rearrange that C3, which is equal to, from here it is equal to C1, and that is equal to P over L into 1 over 6 L minus A whole cube minus 1 over 6 BL square. Clear? Let me check. Oh, this is BL square, BL cube PB over L. C1 is equal to C3 is equal to P by L to 1 minus 6 L minus B L square plus C3L, because there is L with C3 which will cut, that's why we will have 1 power less. Now you have the C1 and C2 value. You can put it in equation number 2. I will write equation number 2 downward again. So equation 2 was EI into y is equal to P over L into 1 by 6 bx cube plus C1x plus C2. As C2 is equal to 0, only C1x, so you can put the value of C1 from here in this equation. So you have to do it by yourself. When you put the value there, let's put it and divide EI on both sides. So you will get y is equal to P over EI clear into 1 over 6 bx cube plus C1 is P over L, so it will be P over L and EI, and it will be 1 over 6 into L minus A whole cube minus 1 over 6 BL square. Clear? So in question it was given that to find the deflection at C. So at x is equal to A, this is point C, this is point C. You have to find deflection. So you have to put x is equal to A. Clear? So you can put it, y will become equal to, I will write the final equation P over EI into L there. So it will be equal to 1 over 6 BA cube plus 1 over 6 B cube into A minus 1 over 6 BL square into A. Clear? You can do it. These are very easy steps. Again, if you are confused here over here, so you can simply put x is equal to A in this equation and simplify it. Clear? Now you have E value that is given in 29 10 to the power 6. You have P value, you have L, you have A and B as well that is given above. Only the value of I is missing. Clear? So I will be taken from appendix of the book, that is I 40 by 30, which is equal to 291. Clear? Inch 4. So you can take the value from here. I is equal to 291 inch 4, and you have rest all the values. Put all the values. I will not put all the values in y. Clear? So we will get yc is equal to minus 33.179 into 10 to the power minus 3 foot, or it will be equal to minus 0.398 inch. Clear? So this is the answer of question. The main important thing is that you have a clear understanding and clear concept. Clear? Rest, you can see that due to this long calculation there may be a mistake, but if you have clear idea, you will go right in every step. Clear? One more thing is that here inch power 4, so either convert the value into feet 4 and put it in this equation, or convert all other values into inch. Yeah, I hope you have enjoyed this problem and learned a lot from this. Thank you for watching and giving your time.